Alright, today we're looking at transformations. Now, when we look at transformations, we'll be looking at linear and exponential. We're going to have a lot of focus on exponential functions, though, because linear, honestly, it's just easier to graph them and compare than comparing off of a and k. So the linear function, the base way we look at it is y equals a times x plus k. For exponential functions, our base form for exponential functions will be y equals a times b to the power of x minus h plus k. Now keep in mind, b is the number, the value being raised to the power of x. Making it an exponential function means we have an exponent that is a variable. So that's what makes that exponential function. We have a few definitions for a, b, h, and k. Now for linear, it's only going to be pertaining to a and k, but exponential functions goes for all a, b, h, and k. For both of our functions, if a is negative, meaning if a is less than 0, there is a reflection over the x-axis. So we'll be reflecting the points over the x-axis. We'll be looking at that more in depth later. If the absolute value of a is greater than 1, we have a vertical stretch by a factor of a. If the absolute value of a is less than 1, we have a vertical shrink by a factor of a. And the last one, if the absolute value of a equals 1, there's no vertical stretch or shrink, so we don't have to describe a vertical stretch or shrink if the absolute value of a is 1. Now b only pertains to the exponential functions, and keep in mind that's the value that's being raised to the power of x. Now for exponential functions, b cannot be 1. So keep in mind, b can't be 1. Now if a is greater than 0 and b is greater than 1, then the function is the exponential growth function. So we've been taking a good look at those, so it'll be in that type of direction. If the absolute value of a is greater than 0 and b is between 0 and 1, so it's not 0, it's not 1, but it's a fraction in between there, then the function is exponential decay function. So that goes the other direction. And today we're going to incorporate when we do have a negative a value and we have a reflection over the x-axis. We'll take a look at what that looks like. If h is positive, there's a horizontal shift to the right, h number of units. If h is negative, there's a horizontal shift to the left, h number of units. Now h also is just pertaining to exponential. And keep in mind, since it's the parent function form x minus h is always going to be opposite of what it appears to be. But it's because the parent function is the form x minus h. So that changes that sign. Alright, k pertains to both linear and exponential. If k is positive, there's a vertical shift up k number of units. If k is negative, there's a vertical shift down k number of units. So let's take a look at that more in depth in the next problem. So we're first going to identify a, b, h, and k, and then we're going to describe how g of x compares to f of x equals 4 to the power of x. So we have g of x for number 1 is 2 times 4 to the power of x minus 1. Now a, keep in mind, we have the parent function form y equals a times b to the power of x minus h plus k. So a is the coefficient of our exponent expression. So our a value here is 2. Our b value here is the value being raised to the power of x, so b is 4. Our h is the value being subtracted from x, so keep in mind it's in the form x minus h. So since it's in the form x minus h, our h value is 1 because it already has that minus sign there. And then our k value is what's being added or subtracted to the entire expression. Since there's no value being added or subtracted, we can think of that as plus 0, so k is 0. Now our a value, taking a look back at the sheet in the previous slide, a is not negative, so we don't have a reflection. Now the absolute value of a, absolute value of 2, is greater than 1. So our first description, we have a vertical stretch by a factor of 2. Now b is the same as b in f of x. Here b is 4 as well, so there's no change there. That's the same thing. H though is 1, and since h is positive, there's a horizontal shift to the right 2 units. So we say horizontal shift to the right 2 units, or 1 unit, excuse me. So that's our transformation of number 1. Number 2, our A value, once again, is the value we're multiplying our exponential part by. We're not multiplying it by an apparent number, but A cannot be 0, because if it was 0, it'd cancel that out. So think of that as 1 times 4 to the power of x. So A is 1. Our B value, once again, here is 4. Our H value, here we're not adding anything to our exponent of 0, so our H value is 0. Our K value is what's being added or subtracted. So since we're subtracting 3, our K value is negative 3. So now, since A is 1, we have no reflection, we have no stretch or shrink, so we don't have to describe that. B is the same as f of x, so we don't have to describe that as well. H is 0, so that's saying we have no horizontal shift, so this graph isn't moving to the right or to the left at all, so we don't have to describe that either. So the only thing we need to describe is our K value of negative 3. And looking back at that definition, if K is negative, there's a vertical shift, so we have a vertical shift down 3 units. Now we don't have to say down negative 3 units because we've already indicated that negative value by indicating that we're going down 3 units. So it's going to compare to f of x by shifting down 3 units. All right, now let's take a look at some graphing. All right, so on the back side, we're given the exponential function. This function is f of x equals 2 to the power of x. Now, keep in mind this continues to go up, and we're bounded by the asymptote y equals 0. So this one also keeps on going. So it doesn't approach, it approaches 0, but it doesn't quite touch it. So we're asked to describe the transformations applied and then graph it. So we're going to graph these and make sure we label them. Now, keep in mind when we graph, it's not going to be exact, but we're going to talk about what each of the transformations are. So for g of x, the first one, keep in mind, but all these b's are going to be 2, so that makes it easier to compare. So our change here is our a value. We have an a value of 1/3. Now, the absolute value of 1/3 is less than 1, so we have a vertical shrink by a factor of 1/3. Now when you think vertical shrink, I want you to think of a rubber band. So I'm going to draw a picture of a rubber band. When we shrink this rubber band, think of as squashing it. So when we squash it, it's going to get fatter. So when we shrink a graph, you're sort of taking it and squishing it between your hands. So you're going to make it expand vertically more. So it's going to look fatter. So for this one, we're going to make this function look fatter. Now it still has an asymptote at y equals 0, because keep in mind that k value tells us our asymptote, but it's going to be a fatter function, so it's going to expand more. So here's g of x. So that's our difference. I'm going to change my pen color to green. All right, so the next one for h of x, that equals negative 1/3 times 2 to the power of x. Now once again, 2 to the power of x is the same. The difference here though, our a value is negative 1/3. Now since a is negative, we first have a reflection over the x-axis, and then we also, just as we did with g of x, we have a vertical shrink by a factor of 1/3. All right, so this one we're going to be using g of x a good bit because it's going to be the same shape. It's going to be shrinking or shrunk by a factor of 1/3. This time though, it's going to be reflected over the x-axis. Now our x-axis, keep in mind, is that horizontal line. And when you're reflecting over the x-axis, what we can do, we're going to take the points that we have and we're going to move them. We're going to see how far away they are from the x-axis. So this point is 1, 2 units away from the x-axis. So to reflect it, it's going to be 1, 2 units away from the x-axis as well. So this unit's about a quarter of a unit away from the x-axis, so it's going to reflect a quarter of a unit on the way, quarter of a unit on the other side of the x-axis. Now when we reflect, it's going to look upside down. We still have the bound of the asymptote y equals 0, so the graph still isn't going to go over that. It's now going to be on the other side. Whoops. Another way to get comfortable with drawing these is to think of patty paper. So when we looked at patty paper, and we'll be using this in class as well, you can draw put your patty paper over your original function, trace it, and then flip it over the x-axis. So it's going to be flipped. So this one's going to be upside down. All right, the next one we're going to take a look at is p of x. Now we're going to skip over some of them. But p of x, we have 2 to the power of x minus 5. The thing that changes here is that k value. We have a k value of negative 5. And since our k is positive, we're moving our original function of h of x. We have a vertical shift down 5 units. Now, we can also talk about our asymptote here. Our asymptote here is going to be y equals negative 5. So it's going to be that horizontal line at the y value 5. Now, that original function, so the line in the black, we're taking that down 5 units. So each point we have on here, we're taking it down 5 units. So 1, 2, 3, 4, 5. So we're vertically shifting every unit down 5 units. So that's 1, 2, 3, 4, 5. We're just going to do one more. And I'm doing ones that are sort of clean, ordered pairs. So we have 1, 2, 3, 4, 5. So we shifted every unit down 5 units. All right. So then this our turquoise is p of x. And our last one we have s of x, excuse me. And for that one I'll use red. And for this transformation, it is our h value, because it's 2 to the power of x minus 5. So since it's 2 to the power of x minus 5, our h value is positive 5. So we have a horizontal shift to the right 5 units. So we have a horizontal shift to the right 5 units. So once again, everything's based off f of x. So I'm going to move each clean ordered pair I can find to the right 5 units. So 1, 2, 3, 4, 5. And this point, 1, 2, 3, 4, 5. And if I do any other ones, they're going to be off the graph. Now this one still has an asymptote, but y equals 0. Everything's just been shifted to the right 5 units. Now, for all of these, another way to graph them would have been to create a table. Our x value is -2, -1, 0, 1, 2, and find the corresponding y values and plot those that way. But transformations sort of gives you an easy way to quickly sketch a particular type of graph. So that's what we did here. We described the transformations, and we took that original function, f of x equals 2 to the power of x, and shifted it based off which transformation it had. Hope you all have a great evening. I will see you tomorrow.